So let's evaluate some limits using GeoGebra. First, I want to show you where GeoGebra is. So notice that there are some links to some ads where you can download GeoGebra through proxy sites. It's best to go to geogebra.org, which is this link right here to download GeoGebra. You can click here where it says download, and depending upon what device you're using, you can run it straight through Chrome if you're running Chrome as your browser. But if you have your own personal computer, I recommend downloading the actual application. It works a little bit faster that way. But if you happen to be on the go, you can use either a Java applet or GeoGebra. I've already downloaded the one from Windows because this is a Windows device. So let's get started. This is GeoGebra, and we're going to evaluate the limits. Let's look at the function sine of 2x divided by 2x. And we're going to look at the limit as x approaches 0. Notice algebraically, if I plug in 0 for x, I see that I get the sine of 2 times 0, which is the sine of 0. That's the height or the y-coordinate when my angle is equal to 0, so that's 0 on top. And 2 times 0 is 0 on bottom as well. So looking at my function, it looks sort of like a dampened sine curve that gets flatter and flatter as I go out. I want to change the view of the function, so I can go up to this multi-arrow, and the easiest way is to just click and drag on the axis, and that'll zoom in on this axis, and I want to zoom in on this axis as well, because we're only interested in the point right where x equals 0. One of the negative features of GeoGebra is that although there is a discontinuity right at x equals 0, that doesn't appear on this graph, that it looks like a continuous function even though there is in fact a hole right there. And as I zoom in even closer, here let's zoom in closer and closer, and I can also move the window as I want just by clicking anywhere on the window and holding and dragging. It looks like my left-hand limit is approaching y equals 1, and my right-hand limit is also approaching 1, and so we would assume just graphically that this function, sine of 2x divided by 2x, as my x values approach 0, it looks like my y value is getting closer to 1, and the limit is equal to 1. Another way that we could evaluate this is by using a spreadsheet, so I'm going to click on View. Right now I have the algebra view, and I also have the graphing view, and if I click here, boom, it gives me a spreadsheet. And what do I want to enter into my spreadsheet? Let's evaluate this function at various values close to 0. So I could start by looking at the value 0, and then I want my output, my b column, to be the y's, which is f of 0. And what is f of 0? It's the sine of 2 times 0, or 2x. I don't want an x here. I want this value, the 0, to be my value. So, whoops, I clicked away and it ruined it. But really what I want is the sine, lowercase sine, of 2 times a1, because that's what that column is the a1 column, divided by 2 times a1. And I'm going to put the 2 times a1 in parentheses on bottom for clarity and see what that gives me. Well, that says question mark. Why does it give me a question mark? It gives me a question mark because it's an indeterminate value, right? We've already talked about this, that our 0 over 0 is an indeterminate value. So let's try something else. Let's try 0.01. And I want the same formula to work down here, so I'm going to highlight that cell, click on the corner, and drag it down, and it gives me value. Notice it gives me the value of 1. Why does it give me a value of 1? That's because of rounding error. That at 0.01 it's very close to being 1. Let's do something a little further away and see what happens. So at a value of 1, which isn't quite visible on this, but if my x value is 1, my y value looks like is about 0.5, and that's what this table gives me. A value of 0.1. I'll click this and drag it down. And then here I'll do a value of 0.01, and it gets me even closer to 1. Clicking and dragging this down. I'll delete these. Delete. Delete. So this is a way to numerically evaluate the tables and the value. Another thing that I might want to do is to go under Options, where it says Rounding, and it's rounding to 2 decimal places. I might want to get more accurate. So let's round it all the way out to 15 decimal places. Now we can see that here, when my x value is 0.01, my y value isn't actually 1. It's actually 0.99993 and a bunch of numbers. And so that's very, very, very close to 1, but not exactly 1. And in general, that's what the limit tells us, that as my x values get closer and closer and closer to 0, we see that our y values are getting closer and closer to 1. I can also do the same thing from the negative side, so I can plug in a value of -1, of -0.1, and then a -0.01. And I'm going to click this square and drag down the formulas and see that this function is symmetric. It looks symmetric graphically, and it's symmetric visually, that as I approach from the left-hand side, my values are also getting closer to 1, and the values agree.